Okay, welcome everybody. I'm Marjorie Kaplan, and I'm joined here by my colleague Lucas Markson. We co-direct the New Jersey Climate Change Resource Center here at Rutgers. I'm going to be your moderator for today's Climate Academy, focusing on our recently released report, The State of the Climate New Jersey 2023. Lucas is going to be assisting me in monitoring your chat and questions for our distinguished panelists, and it's our pleasure to welcome you all. Today's webinar is a scientific overview of outstanding 2023 weather events, providing a more in-depth analysis of historical climate data and projections for New Jersey. Our webinar is going to last until 12:15, and other than today's presenters and our Rutgers team, you're all muted. So to communicate with us, please type your questions into the chat box. And please make sure you send your notes to the panelists. That's ensuring all of us working behind the scenes today will see your questions. We are recording today's webinar, and it'll be available on the Resource Center website, which I'll put into the chat box in a second. And we're hopeful that we'll get it up today, but it may not be for the next 48 hours. It just depends on sort of how things go here. The report we're presenting on today can also be found on our website, and I'll put that in our link. And I also want to thank our wonderful colleague, Matt Drews, who's with us today. He is our digital media specialist for all things climate here at Rutgers. Today, we are pleased to have an amazing constellation of speakers. We have Dr. James Shope from the New Jersey Ag Research Station and the Department of Environmental Sciences. We have Dr. Anthony Broccoli, Distinguished Professor in the Department of Environmental Sciences. We have Dr. David Robinson, the New Jersey State Climatologist and Distinguished Professor in the Department of Geography. And we have Lori Garza, Research Analyst in the Department of Marine and Coastal Sciences and the Center for Ocean Observing Leadership. With that, I'd like to invite Professor David Robinson to turn on his camera and microphone to kick off our event today by discussing 2023 in review. So take it away, Dave.
Thank you very much, Marjorie. Good morning, everyone. And hopefully you're up and seeing things operating here. Okay, I'm going to give you a little retrospective of 2023 weather and climate around the Garden State, and cheat a little bit and talk about the first half of 2024 briefly as well. So let's get right to it. Every year, State Climate Office puts together kind of our top 10 events of the year. It's online. We publish it each year online. These are our 10 for 2023. And I'll be frank with you, they weren't all that exciting compared to other years. And that's not a bad thing, not a bad thing at all. But we have a little bit of fun with this, but obviously take it seriously because some of these events are far from fun. But you can see our highlights from 2023 was the frequent smoke that came into our area at high levels of the atmosphere and on particularly June 7th, right down to the surface, from fires that raged from Western to Eastern Canada for the most part. Moving on quickly, we also had as they say, a tornado bonanza. There were 13 of them. And 7 of them occurred on April 1st, which tied the record for the most in a day. This 13 tied for the second most of any year on record since 1950. But there's no trend. Let me add there is no trend. We had a large number for a few years there in the late 80s, early 90s. And in the last several years, we've had a fair number, only one very weak one so far in 2024, and let's hope it stays that way. It was another warm year. I'll show you that in a minute. It was the 3rd warmest year on record in New Jersey. I will get back to that. At the end of the previous year for snow, the previous winter ending in the spring of 2023, it turns out it was our 3rd least snowy winter on record in New Jersey and the least snowy from Monmouth, Mercer, Middlesex County south. We did a little bit better in 23-24. Check out the State Climate website in a couple of days, and we're going to have a map up there that talks about this previous snow season. December deluges, we'll go back to that in a minute as well. It was a record wet December. There were a number of wildfires. The New Jersey Forest Fire Service reported, I believe, was a record number throughout the state, up in the highlands, but mostly in the pinelands, a few in the meadowlands types regions, marsh regions. But fortunately, no deaths or major injuries or a lot of property damaged. There was a major deluge following a very wet period up in Warren County in July that led to a landslide that closed Route 46 for a couple of weeks. We provided data to FEMA that got some support for cleaning up that mess. Late September, Ophelia came along and stayed in one form or another and gave us a heck of a lot of rain. The growing season, this is always something very interesting, but usually doesn't make the top 10. It was over 3 months longer, almost 4 months longer down along the southern coast than up in the valleys of Northwest Jersey, where the cold air can pool in and give early October to late May freezes, when along the coast it might only be from Thanksgiving or mid-November until late March, early April. And then we had a lot of warmth. Moving on, this is a precipitation map for the year. Most of the state had above normal precipitation. The areas in red in the Pinelands and the Southwest were just a bit below normal. This red area down in southern coast is normal to get under 45 inches of rain in a year. And the highlands, usually the wettest part of the state, were this past year and above normal at that. Two temperature maps showing the mean maximum temperature for every day of the year of 23 on the left, mean minimum temperature on the right. You see more of a latitudinal distribution for maximum temperatures, with some differences along the coast, a little cooler, and up in the higher elevations. But when it comes to low temperatures, you can see how cold southern inland regions can get in the Pinelands. And you also see some indication there of urban warmth up in the New York metro area and down the Philly metro area. Looking back, the top left figure here is a bar graph of precipitation departures from normal every month of 2023. Green bars were above normal. We annotate the figure when a season or a month makes the top 10 back in 1895. And you can see we had a very wet September and a record wet December. The lower right takes the last 12 months going back to last July to just this past June. And you can see we had a number of wet instances during that period that kept the reservoirs full and kept us a little bit prepared for some of the dry weather we've had of late, but we have to keep our eye on that. Looking at the same type of figure, bar graph for temperature, the top left is 2023, and you can see 8 of the 12 months had above normal temperatures. The last 12 months you can see have even been warmer. We've gone 7 straight months with above normal temperatures. The winter was in the top 10. The spring was in the top 10 for warmth. So on we go. And of course, we share this globally. I'm going to very quickly touch on these and pass it on to James because he's going to talk more about time series. But to put into context what we're seeing going on since 2023. 2023 was, as I think most of you listening and watching know, was a record warm year. This year we're still on a record pace, but we were almost off the charts literally in 2023 globally. And New Jersey followed, but it was only the third warmest on record. I should add that the first 6 months of 2024 are the second warmest on record. Only 2010 was slightly warmer than the first 6 months of 2024. And we'll see where we go from there. 2010 ended up being the warmest year on record thus far. There you can see a list of the top 10 warmest years, including up to 2023. And you will note that 9 of the 10 have been in this century, and only 1998 snuck in to the top 10 from an earlier decade. Precipitation-wise, we ranked 29th wettest in 2023. but you can see an overall general wetter pattern, and a pattern with a lot more interannual variability in precipitation than in the first half of the 20th century, for instance. And here's a figure I know Tony loves. I've worked on this with the state geologist, who's now Steve Domber, for a number of years now. Just quickly, this figure shows you in the top, any month that was in the top 5 for that particular month in terms of warmth is a red box. Any that was in the top 5 for cold is a blue box. So there's 60 possibilities here. 12 months times the 5 for the warmth, and same for the cold. And you'll notice that 80% of the top 5 warm months in any given month, on record back to 1895, 80% of them have been since 1990. And during that period of time, I defy you to find a blue box, because there's not been a top 5 cold month in that period of time. Just an amazing shutout when we look at it, and even more pronounced when you just look at the 21st century. For precipitation, it's a little more variable, although you can see the darker blues and the darker reds more towards recent decades, and those are among the very highest, the first or second wettest months. As it pales out, it gets into 3, 4, and 5. So with that, we'll let sea level go too, but I want you to just note it's rising and may be accelerating. And with that, I am going to stop sharing my screen and pass it on to James. Thanks very much, everyone, for joining us today.
Thanks so much, Dave. So James, you're on to discuss the Canadian wildfires from last year and give us some updates on historic climate trends and future projections for New Jersey.
Awesome. Thank you so much, Dave, for that great summary. And thank you, Marjorie. So as Marjorie just mentioned, we're going to review, one of the top 10 events of last year as given by the State Climate Office with the 2023 Canadian wildfires. And we want to talk about those because even though they're external to New Jersey, they had a very real effect on the state. So it's worthwhile to cover them. So May through June of last year was the warmest period in Canada kind of as a whole since 1940. And with those warmer temperatures also came very low humidity. So higher temperatures, less humidity creates drier forests that are more susceptible to wildfire. And so in Canada, most of the wildfires there tend to be sparked by lightning. And that's what happened and led to the kind of wildfires that we experienced last year. You can see that pictured here on the right. I'm actually going to get a little laser pointer. So this is a satellite image of fires burning in Quebec province. And across this May through June period, over 32 million acres of Canadian land burned, releasing some 480 megatons of carbon. Now, wildfire smoke contains a number of different pollutants, like fine particulate matter, PM2.5, carbon monoxide, nitrous oxides, as well as volatile organic carbon. But they also release greenhouse gases, primarily CO2. Now, when we want to think about how that affected us, stateside, large swaths of the US were affected during this period. And what I'm showing in this graphic here is a particular day, June 7th, where the winds brought smoke and very poor air quality towards the mid-Atlantic and northeast corridor of the US. So you can see through here that we were exposed to unhealthy to very unhealthy conditions throughout parts of New Jersey, which is a little bit hidden here. Now, we should note that this data comes from airnow.gov, which pulls data from EPA as well as in the state of New Jersey, DEP air quality monitoring stations. And across this entire period, May through August, when wildfire smoke was impacting the US, emergency department visits for asthma were about 17% higher than expected. So we saw a very real impact from events outside of our own borders in terms of climate change effects, wildfire effects. So as Dave Robinson mentioned earlier, we had kind of two main episodes to poor air quality in the state from these. First was what I showed earlier on June 6th. This is measuring the AQI. That's the air quality index. Basically, the higher the number, the worse the air quality is. And we had another event that was centered on the 29th through 30th. So we had two of these big events, and then we are showing some lines from different locations around the state just to show that there was a large amount of agreement between all these sites. Now, there was one small spike here in Brigantine that had nothing to do with Canadian wildfires. It was due to a local wildfire near Brigantine, just to show you why that deviated. So what does this mean for climate change in New Jersey forest fires moving forward? So New Jersey's land is about 40% forested area, and it's prone to a number of wildfires each year. And in fact, 2023 was an abnormally active fire year, as proclaimed by DEP, where wildfires burned over 18,000 acres of New Jersey land. So pictured here on the right is actually from last year, but it's a wildfire event down near Lakehurst. And this plume of smoke is not necessarily something uncommon. And when we think about what causes our fires in New Jersey, about 99% are anthropogenic, basically human caused from one reason or another. So Canada, lightning strikes, more natural. Here in New Jersey, more human caused. Now, how do we expect these to change and affect us in the state with climate change? First, wildfire emissions themselves contribute to climate change. I mentioned before that they produce carbon dioxide and other greenhouse gases, and that can lead to a feedback loop of warmer and drier conditions overall that can become more conducive for wildfires. The frequency and severity of these wildfires can affect forest regeneration, thereby decreasing carbon stocks in our forests as well. And so as we experience more severe weather and more hot and dry conditions as our climate warms here in the state, we expect to see increased wildfire exposure at the human level. So that's going to be exposure to the actual fire themselves, as well as exposure to the pollutants. And if we want to put that in perspective, because I only have this number at the global scale, about 250,000 to more than 500,000 deaths worldwide are annually caused due to landscape fire smoke. And as wildfire conditions become more conducive with climate change, we expect that to increase and increase within our borders here in New Jersey as well. Okay, so shifting from talking about individual events, I want to talk about kind of climate change writ large and its trends and projections for the state of New Jersey. And first, that should start with a discussion of our global climate drivers. So, brief overview, the combustion of fossil fuels, coal, petroleum, natural gas, and others, emits carbon dioxide into the atmosphere, as well as other greenhouse gases. And we emit a ton. That's a bit of a joke. We emit about 10 billion tons of carbon per year. The graphic down here shows our concentration of carbon dioxide in the atmosphere as measured at Mauna Loa Observatory in Hawaii from the late 1950s to today. And you can see that it's increasing and increasing at a faster rate. And we're currently generally above 420 parts per million as we are here in 2023 to 2024. Now, carbon dioxide is the gas that we focus the most on, but it's certainly not the only one. This graphic here is showing the contribution or the relative contribution of various greenhouse gases to warming each year. So that's what this radiative forcing entails. The cyan color here is carbon dioxide, and you can see it's the vast majority. It's more than 60%, followed by methane, nitrous oxides, and chlorofluorocarbons. So we target and talk about carbon dioxide because it makes such a large fraction of our emissions and responsibility for observed warming. And this has led to an increase in global temperatures by about 2 degrees Fahrenheit over the past century. So Dr. Robinson showed this graphic a little bit earlier, so I won't belabor it. But our temperatures relative to the average of the last century, so that's what's pictured here with our average annual temperature in black and the smooth trend through that in red, have generally been increasing. And since about the 1970s, 1980s, they've been increasing at a much faster rate. So we are warming more as we go along. And we anticipate that trend to continue into the future. This graphic here is from the Intergovernmental Panel on Climate Change, showing change in global temperatures relative to what we call pre-industrial conditions. It's in degrees Celsius. Most international documents are. The black line represents what we just saw, historical information, and then we use a suite of potential scenarios of how our emissions may evolve to get a sense of what the future may hold for us. So I won't go into these too much, but we have a low suite of emissions here in blue, showing reduced emissions and therefore reduced warming, and a higher suite here in red showing more emissions and greater warming. Based on our current policies and trends today, we're somewhere in between this SSP2 here in gold and this SSP3 in red. And that puts us at 2.7 to 3 degrees Celsius above these pre-industrial conditions by 2100. So we expect to see more warming as we go along. That leads to a number of downstream climate effects like more intense storms, heavier rainfall and potential flooding in some locations, drier conditions to drought conditions in others, think the American West, or as we discussed earlier, dry, warm conditions that are conducive for wildfires. Now, let's actually get into New Jersey itself now that we have this kind of larger background. And we're going to start with temperature and heat. So as we saw with the global temperatures, New Jersey temperatures have been increasing. So this is our average annual temperature in black. Again, the red line is just a smooth trend through that. And in New Jersey, our temperatures have increased roughly twice the global average. So about 4 degrees Fahrenheit since 1900. And if we look at the rate of that change, that's what's in blue here, you can see that overall the rate of change since 1900 has been about 0.33 degrees Fahrenheit per decade. But if we say change that to measuring it from 1970, that rate becomes 0.66. So effectively showing that our rate of warming in the state has been increasing in recent decades. And we see a lot of that increase more so in the winter months. Looking to the future, we can look at some of those scenarios that I showed you earlier, specifically for New Jersey. And in this case, I'm comparing a moderate and very high scenario. And by the end of the century, compared to effectively what averages out to 2005, we expect temperatures to be about 4 to 6 degrees warmer with moderate emissions, a bit closer to what we're trending towards right now, and 7.5 to 11.5 degrees higher by the end of the century with very high emissions. So we're locked in for warming here in the state of New Jersey, but we can modulate that based on global emissions. Now, this warming will have a number of potentially detrimental effects downstream. What's very worrisome here in New Jersey is the effects on the urban heat island. New Jersey is a very urbanized state with high densities of pavement and other impervious surfaces that absorb solar radiation and re-radiate it back out as heat. That can cause areas like cities become warmer than their surrounding locations. And we worry about how that may impact heat and health, especially in our urban centers moving forward. So we expect in the future to see higher instances of heat stress, as well as heat-related illnesses and morbidity. Extreme heat also degrades our air quality. So absent of wildfires, certain pollutants like ground level ozone are created at a higher rate on hot days. So that's very bad for folks with asthma or other respiratory illnesses. We also expect to see an increase in vector-borne diseases. Certain species of mosquitoes, for example, have their range north curtailed by winter temperatures. And as it warms, they can expand into new territory, bringing diseases like West Nile virus with them. And also, in a more mundane sense, we expect that higher temperatures will affect our infrastructure and power grid. Basically, these systems wear and tear more so on hot days, or we turn on our ACs and use our power grids more. Okay, so going from temperature, I want to discuss sea level rise because it's a very direct consequence of warming global temperatures. So again, we're in a graphic from the IPCC showing change in sea level relative to 1900 in meters. The black line represents our historical information at 2020. And you can see that since then, global sea levels have been increasing at an accelerating rate to about 1/4 of a meter by 2020. Now, if we follow our scenarios that we discussed earlier out, you can see that we have a range, but based on what I said we were trending towards before, we're looking at about 3/4 of a meter by 2100. Now, do me a favor and ignore this low likelihood storyline for now. But what we can see is that we're in for some amount of global sea level change. Now, global change is not necessarily what we experience here in New Jersey. We have local effects that drive us to see higher rates of sea level rise on the ground, as it were. This image here from EPA shows change in sea level between 1960 and 2020. And it has here the relative change in inches at a number of different tide gauges around the country. And in Atlantic City, for example, our rate of increase is more than 8 inches over this period. So what's going on here? At the global level, you have two really big contributors to sea level rise. One is as temperatures warms, ice sheets and glaciers melt, that water funnels into the ocean and fills it up like a bathtub, as well as the ocean itself, as it warms, will expand its volume a bit, and that can cause noticeable sea level rise on the surface. Now you have other effects like changes in circulation patterns, changes in salinity and the like, and then you have extremely local effects. And we can get into it a little bit in the Q&A if you're interested, but primarily what's happening in New Jersey is that our land is sinking over time along the coast. This is due to natural sediment compaction, natural adjustment due to the effects of the last ice age. But the fact of the matter is, because of that sinking, our rate of sea level rise is much higher than many other parts of the country. And if you actually look at the total amount of sea level rise in Atlantic City, it's been about 18.6 inches since 1911. And looking to the future, Rutgers actually releases a report looking at the sea level rise projections, in this case for moderate emissions, compared to the year 2000. And by 2100, we expect this likely range of change indicated by this tan region to be about 2 to 5 feet of sea level rise on New Jersey's coasts. And this red line here represents the median, or our best guess estimate, of about 3.3 feet, which is about a meter conveniently. Now, people think of the encroaching tides as the kind of big issue with this, but one of the things that's going to hit us first here in New Jersey and has already affected us is how storm surges intersect with higher sea levels. Storm surge basically stacks upon your existing high tide. And when you have a higher sea level, it shifts that baseline higher, and your storm surge can now affect inland further and cause more damage. And we've seen that effect with Hurricane Sandy already. So this is pictured over here, the storm surge extent of Hurricane Sandy, and it's been estimated about 13% of the property damage from Sandy can be attributed to the fact that sea levels are higher due to human effects. So that's to the tune of about $4 billion. So if we want to put this in kind of this climate change view, the same coastal storm today would cause more damage than the same one 50 years ago. And that our large coastal flooding events are going to become a lot more frequent in the future because you don't need as big of a storm to generate the same levels of flooding. Now, we also do want to discuss the kind of lower level flooding. You'll hear this called tidal flooding, nuisance flooding, sunny day flooding. And it's just basically where, absent of any storm effects, your high tides are high enough that they flood inland and cause this low level of flooding that you can see here in this picture in Mantoloking. Homes are cut off, this road's flooded, and the issue here is more the frequency. It's based on the tides, and with sea level rise, your tides can cause this kind of flooding much more frequently. Okay, so I want us to wrap up this section talking about precipitation and storm effects. So New Jersey's annual precipitation has not changed dramatically since records began. Now, it's become much more variable, as Dr. Robinson mentioned. So this graphic here in green is showing the average annual precipitation amount. You can see that graph becomes decidedly more spiky as it goes along. But if you were to look at the overall trend indicated by these black bars, which represent decadal means, you can see there's only about a 7% increase in rainfall since the 1900s. And we anticipate that kind of smaller increase to continue. So looking at projections of rainfall by the end of the century with moderate emissions, we expect to see about 3 to 13% higher than the 2010 average. Now, if you want to look at that spatially, this graphic over here is for the mid-century estimation for moderate emissions. And you can see that a large swath of the northeastern part of the US, the Midwest, are seeing maybe about 1 to 2 inches of increase in the total amount of rainfall. Now, that doesn't seem like much And where kind of the larger climate story is with extreme rainfall. So extreme rainfall in New Jersey is becoming more frequent and more severe. And we can see that in terms of the number of 2-inch precipitation events. And that's what's pictured here on the right. The black dots represent the average number of 2 inches of precipitation events in the state of New Jersey per year. The green bars represent the 5-year average of those. If you were to fit a line to this, you would see that it's basically increasing over time. And if we look at projections from the Department of Environmental Protection and Cornell University for our extreme rainfall events, we expect them to be about 2.5% to 10% greater in kind of the southern, central, and coastal parts of New Jersey, and about 20 to 25% greater in northern parts of New Jersey. And all this is to say that our planning and guidance on extreme rainfall tends to be based on historical information, but as we're seeing, we should supplement those with model projections to help account for future effects. And obviously, the effects from this extreme rainfall are pretty straightforward. Causes flooding, property damage, contaminates food and water. We can see more pollution from combined sewage and overflow runoff into local waterways. Basically, our sewage from our buildings and stormwater is combined into the same network in many locations, and it can overflow the system, and that gets spilled out into a river or other local waterway. Extreme rainfall also can harm agriculture, reducing growth, delaying planting, causing diseases like root rot. And one concern as we're moving forward is we know that the total amount of rainfall in the year is not really projected to change much, but that our events are going to become heavier. So what we expect to see in the future is more rainfall during these heavy events, and then drier to drought conditions in between. So this boom bust cycle of heavy rain, drought, heavy rain, drought. Now, I want to wrap up talking about how we think storms may change in the future, specifically tropical cyclones, because we are, looking at what's projected to be an extremely active hurricane season in the Atlantic. And what we know is that warm waters fuel more intense hurricanes. So you need warm water, warm, humid air. As the ocean warms, as the atmosphere warms, we expect more of our hurricanes to be in the Atlantic to be more energetic, so greater fraction in categories 4 and 5. We expect them to intensify more rapidly before making landfall, which happened here. This is Hurricane Ida before making landfall in Louisiana. It jumped up in category, intensifying, making it hard to plan for those effects. And we virtually expect them all to generate more rainfall, which, as we know here in New Jersey, we're subject to a lot of rainfall-driven flooding, which can be problematic in the future. Okay, so with that, I'm going to wrap up this section, and I'm going to turn it over to turn it back to Marjorie to introduce Dr. Anthony Broccoli.
Thanks, James, so much. And thanks everybody for your questions. We're going to get to as many of them as we can during the Q&A session. So please be patient. I'm going to turn it over to Professor Anthony Broccoli now, who's going to briefly discuss potential climate change acceleration. Thank you. Tony, you're on.
Okay, thank you, Marjorie. I'm going to get my presentation ready here. And hopefully that will come up shortly. I'm not sure why we're not seeing it. Let's try that again.
I think it's there. I think we're good. Yes, Matt, we're good.
Thank you very much.
Yes.
And thanks to everyone who's here today joining us. I'm going to start out by showing a graph that you've seen before a couple of times, because Dave and James both showed this graph of global temperature. It's looking a little bit differently here because we're looking at a scale in degrees Celsius and a different reference period, but the underlying data are the same. They're showing the year-by-year temperatures globally in the black squares, and then a smooth version of them in the red. And so the question is, looking at the last 10 years or so of this record, is there an indication that global warming is happening more rapidly? And the unusually high temperature in 2023 is one of the motivations for that. But in order to answer that question, we have to understand a few things. First of all, many of you probably know that an El Nino developed during 2023, and the temperatures tend to spike up in El Nino years. So we see these upward spikes associated with the big El Nino in 1997-98, another one in 2015, 2016, and then, of course, what we've seen in 2023. So if I'm a detective trying to figure out what's been happening with the temperature, my first suspect might be El Nino. But the jump in temperature from 2022 to 2023 was unusually large. In fact, it was the largest one-year jump in the NASA GISS temperature record going back to 1880. So that's an indication that there may have been something unusual going on. Furthermore, 2023 began setting monthly temperature records before the El Nino intensified. So it was already on track to be an unusually warm year even before El Nino took off. So what's another possible explanation for this rapid warming between 2022 and 2023? Well, one thing we can do is think about the fundamental physics here and think about Earth's energy balance, which I'm going to illustrate in this little cartoon. So the sun is heating the Earth through the visible light that the Earth receives from the sun. That's the Earth's heating mechanism. But the Earth also has a cooling mechanism in that the Earth emits infrared energy back to space. So what happens to Earth's temperature is determined by the balance between the energy coming in from the sun and the energy that's being radiated back to space in the form of infrared energy. When we put more greenhouse gases into the atmosphere, it makes it harder for the Earth to emit infrared energy to space. And that can create an imbalance between the energy coming in and the energy going out. And if there's more energy coming in than there is infrared energy going out, Earth's temperature will increase. And that is what has been responsible for the increasing temperatures over time. We've been putting more greenhouse gases into the atmosphere, creating an imbalance between the energy coming in and the energy going out, and that has allowed the Earth to warm. But there is evidence that the energy imbalance has been growing. Specifically, here's some data that have been put together by Dr. Jim Hansen of Columbia University, formerly of NASA, one of the world's most renowned authorities on climate change. And Dr. Hansen's data show that the energy imbalance has been growing, and these are measurements based on satellites. As you can tell, the imbalance goes up and down quite a bit from month to month and from year to year, if you look at the thin blue line in this graph. But overall, there has been a tendency for that imbalance to increase. And this increase in energy imbalance may be producing an acceleration of global warming. Now, it's not a simple story, and so I wish I could give you a yes or no answer to the question, is global warming accelerating? But instead, I think my answer is going to be maybe. And one reason is that it is plausible with an increase in energy imbalance that the warming rate would also increase. So the physics makes sense there. There's also a reason why the energy imbalance may be changing, and that is a reduction in sulfur dioxide pollution from commercial ships. When sulfur dioxide gets into the atmosphere, it forms tiny droplets that can reflect sunlight. And so if you reduce sulfur dioxide pollution, which is a good thing because sulfur dioxide has very harmful impacts on human health, you're actually reducing the amount of reflected sunlight. And this trend could contribute to the change in the energy imbalance. But it's not so straightforward because measuring the energy imbalance is very challenging. And there isn't at this time a consensus on whether it has actually increased. Also, as you saw in the graph that I showed you and that Dave and James showed you earlier, global temperature fluctuates considerably from year to year. And so that makes it more difficult to know if what we've seen is just a one-off, something that that happened in a particular year, or if it represents a change in the warming rate over a longer period of time. So what will it take to answer this question? Continued measurements of temperature and of Earth's energy imbalance will eventually provide an answer to this question. And I think that probably maybe as little as 3 to 5 years down the road, we'll be able to know for sure if global warming has been accelerating. Thank you.
Thanks, Tony. Really appreciate it. Finally, we're gonna wrap it up with Lori Garzio to discuss 2 marine stressor events off the coast of New Jersey from last year and how they impacted our marine resources. So Lori, we're gonna switch it over to you.
Thank you very much. Can you see my screen?
Yes, it looks good from here. Matt, you can see it?
Yep.
Okay, great. Hi, everyone. I am a research analyst in the Rutgers Center for Ocean Observing Leadership, which is in the Department of Marine and Coastal Sciences. This basically means that I am in the hold on 1 minute. Okay, sorry. Let me start over. I'm a research analyst in the Rutgers Center for Ocean Observing Leadership in the Department of Marine and Coastal Sciences. And this basically means that I am in the daily weeds of all of the data sets our lab gets from a variety of different sources and technologies. So today I'm going to focus on some satellite-derived sea surface temperatures from 2023, as well as a multi-stressor event that occurred in the waters along the New Jersey coast last summer that was captured by several autonomous underwater vehicles called gliders that we had deployed off the coast of New Jersey. Looking at the broad global ocean, there has been a decades-long positive trend in the heat content anomalies. However, in looking at trends in ocean warming spatially and regionally, warming isn't uniform throughout the entire ocean. Some locations are warming more rapidly than others, and the U.S. Northeast Shelf, which includes the local waters of New Jersey, is one of the most rapidly warming regions on the planet. Zooming in on that Northeast Shelf, we looked at trends in satellite-derived sea surface temperatures for the representative middle month of each season in 2023. So January, April, July, and October. We calculated 2023 SST anomalies compared to a 15-year climatology. Winter, spring, and summer surface temperatures were about 1 to 2 degrees above the climatology, and the warmest departures were during winter, which is January, that upper left-hand panel. And in the fall, which is the bottom right panel, the Kohler SST anomaly is likely a result of the passing of Hurricane Lee that happened in September of 2023, where deeper, cooler water was mixed up to the surface. Another feature to note is the strong warm anomaly and adjacent Kohler anomaly just to the south, which is indicative of the diversion of the Gulf Stream to the north that happened last year. Moving on to the multi-stressor event that happened last summer. For some background, we know that ocean acidification is driven by the ocean's absorption of increasing atmospheric carbon dioxide. Ocean acidification can have damaging effects on a variety of ocean organisms, particularly those that make their own shells and exoskeletons. Lower pH goes hand in hand with lower aragonite saturation state, which is a proxy for how easily organisms can make their own shells. Another stressor for marine organisms is the expansion of oxygen minimum zones, which can be exacerbated by strong stratification. So stratification is where warm surface waters overlay cold bottom waters, creating a boundary layer that limits vertical mixing between those two layers. Then the consumption of oxygen from biological activity, which is coupled with that strong stratification layer, can cause bottom waters to become depleted of oxygen, which is then obviously bad for organisms that live there that need oxygen. So these measurements were all collected using gliders, which dive and surface and measure properties throughout the water column. The top panel for each of those seasons shows the glider track along the New Jersey coast. And to set up what happened last summer, and this seasonal progression is pretty typical of what we usually see. So starting in the spring, the water column is generally well mixed and uniform, with colder water temperatures throughout the water column, and higher pH and aragonite saturation state, which is generally better for calcifying organisms. And those are shown in those bottom two graphs. From August to September, there was strong stratification that developed along the coast of New Jersey, with warm surface waters overlying cold bottom waters. This is typical for late summer in this region, and these are the conditions where we might see low dissolved oxygen values in bottom waters, which can also be associated with lower pH. Then in September, Hurricane Lee passed through the region, which helped break down the stratification at the end of the summer and mixed up the water column. So focusing in on that summer event with that strong stratification, we did detect low dissolved oxygen and pH in the bottom waters across much of the New Jersey shelf. Oxygen values that are less than 5 milligrams per liter are considered stressful for many marine organisms and are highlighted by those yellow-orange colors. And hypoxic levels of dissolved oxygen, which is less than 3 milligrams per liter and highlighted in the red colors, were observed at shallower, more inshore locations. And these are conditions that can be detrimental to marine organisms if those conditions persist. And low, generally stressful pH and aragonite saturation state values are highlighted in blue. And while different organisms have different sensitivities to these values, shells can begin to dissolve when aragonite saturation state drops below 1. The spatial distribution of the hypoxic dissolved oxygen is highlighted on the glider tracks with the magenta colors, and the low aragonite saturation state values are highlighted in blue. And just a note that the inshore glider did not measure pH or aragonite saturation state, so we don't know what those values were at those inshore locations. During this event, mortalities of fish, lobsters, and crabs in the area were reported along the open bottom and not just in isolated pockets. And this suggests that if low dissolved oxygen was responsible for these mortalities, the affected area may have been extensive enough that the mobile fish could not have easily escaped these unfavorable conditions. And then healthier dissolved oxygen, pH, and aragonite saturation state were restored in bottom waters during the offshore passage of Hurricane Lee in September. And then finally, a strong storm in late September drove water column mixing that restored consistently healthier bottom water conditions.
Lori, have you completed your talk? I wasn't really sure. Sorry about that.
Yes.
Okay, I'm sorry. Thank you so much to all of our speakers. I'm going to invite everybody to join us on camera for Q&A. There's been a very active chat box, so thank you for an active set of questions. We're going to get to the questions as opposed to the comments. We'll do our best to get to as many of them we can. My colleague Lucas Markson's been monitoring it, so I'm going to turn it over to you, Lucas, to call through the questions and direct them to our panelists.
Sure. Thanks, Marjorie. This one goes to Dave and also to Tony. Just to clarify, just kind of elaborate, what were the direct reasons for 2023 and this year having the hottest temperature records?
Tony covered some of that. You know, it's whether you're talking globally or locally, but Tony, you know, you mentioned the El Nino event, the possible impact from the improved ship pollution. There's also variability, natural variability in the climate system that can contribute as well. So it's very difficult to pin it down to and attribute it to one particular source, whether we're talking globally or in particular for New Jersey. Tony?
Yeah, I mean, at one level, what's been happening, if you step back and look at the big picture, is that because there's more greenhouse gases in the atmosphere every year, that's going to provide more of a warming effect. But what we actually see, as Dave said, is the combination of the effect of greenhouse gases and also just the natural variability of the climate system that includes El Nino. So typically, the years in which we break global temperature records are years in either of an El Nino or following an El Nino. So in that sense, what we saw in 2023 is not unexpected. It's the combination of increasing greenhouse gases and the fact that there was an El Nino. The possible decrease in sulfur pollution would be making the rate of change greater. But it, of course, doesn't change the fact that we have been undergoing a sustained warming for many decades now. So
Yeah, and I think what's interesting there, Tony, is that in 1998, we had a major El Nino and it set a record high temperature. Then 2016, another major El Nino set a record high temperature. So each time the bar is going higher because it's on a greater foundation of anthropogenic warmth that El Nino event is multiplying or adding to.
Exactly. That's we're seeing that combination, and we'll see what happens in 2024. But it's off to a warm start for sure.
Thank you both. James, we have a few questions for you. I'm going to start with a few that are more definitional that you can try and help out with. First one is just if you can explain quickly, what does the 100-year 24-hour event mean?
Yeah, so that's a lot of jargon. What it means is, in the case of like a rainfall event, it's the amount of rainfall you get in 24 hours with a frequency of occurrence or probability of occurrence of 1% each year. And we used to call that the 100-year event. We're trying to move away from that nomenclature, but it's still in the public consciousness.
Great. The next one question we had was, what global warming potentials were being used in the chart you were presenting? Were they 20-year, 100-year?
They're 100-year because that's standard.
Thank you.
Yeah.
Some of the other questions we received, what % of CO2 in total New Jersey greenhouse gas emissions are represented by the forest fires you presented on? Do you have an idea of that?
I actively don't know, and I'm not 100% certain if those data exist or not, because I imagine it could also be pretty hard to parse that out.
Yeah, thanks.
I'll just jump in there and say I think the percentage is relatively small.
Yeah.
Just because of how large the anthropogenic component is.
Great, thank you both. James, also, how much of New Jersey's above average warming trend is due to the fact that it's more urban, densely populated than other parts of the world?
On the data that we've shown so far, it's not, because those data that we pull from Dr. Robinson's network and the like, they are not geared to get those really local, like urban heat island effects. They're meant to get the kind of statewide effects. So I don't know, Dave, there may be like a small signal in like a couple of stations, but in general, we're looking at the state as a whole rather than like the urban heating, right?
Well, we also have to look at the fact that New Jersey's been an urbanized state for quite a few decades, and we're seeing major warming in recent decades. So it doesn't fit. Maybe there is, and I absolutely believe there's an urban heat effect on some of our weather stations, but it's been there all along, and we're not suddenly getting any more urbanized. New Jersey is very progressive in the preservation of open space in this day and age as well. So that can explain the trend we've seen in recent decades.
All right. Next question for you, James. Why is New Jersey's sea level projections higher or different than the global one?
So I covered this a little bit. There's a number of different factors that play into that regional effect. And some of it, frankly, is physics that I don't want to get into. But the big thing is, in our coasts on New Jersey, our land is sinking over time. So when you have a station like a tide gauge that's measuring your water level, it's influenced by the fact that it's on land that is sinking. So as mentioned before, we have natural sediment compaction along the coast that causes sinking, as well as adjustment of the land surface elevation due to the effects of the last ice age. Basically, there was ice near New Jersey that pushed it up in a bulge. Now that the ice is gone, things are rebalancing and New Jersey's land is sinking over time. So it's a very non-negligible effect, but it's a pretty big effect here in New Jersey.
Great. The last one I have for you from your initial presentation, why would extreme precipitation be predicted to be more frequent in northern New Jersey than southern?
That is what the models and the report has. I am not 100% certain. My guess is it has something to do with the topography in the north a bit more, but Dave and Tony may be able to speak more to that.
Yeah. All right.
Well,
Tony,
I
okay.
just one thing about that. We know that we get more of our rainfall in the summer, for instance, by thunderstorms than coastal storms, for instance, and the coastal areas are drier in the summer than inland. It may be that there's expected to be more of a summer increase in those type of storms that could contribute, or it could be something dealing with the resolution of the model results.
All right, we're going to shift a little. So Tony, we have a few questions from your presentation. One of them was, so was Ida more intense as a rain episode by the time we got to New Jersey because of the hot, humid conditions within the continental US as it moved up to the north?
So for Ida, I wouldn't say that the storm itself was more intense in terms of its winds, because its winds were not particularly intense when it reached New Jersey. But a warm, humid environment certainly allows for heavier rainfall, and that was really the big impact of Ida here in New Jersey, especially the rapid rate at which the rain fell in a short period of time.
Great. There were a few clarification questions regarding some of the things you discussed. Is it true that the ozone layer is starting to repair itself?
Yes, because the Montreal Protocol in 1992 agreed to phase out the types of chlorofluorocarbons that were particularly harmful for the ozone layer. The concentration of those chemicals in the stratosphere has been decreasing, and as a result, it's allowed the ozone hole to kind of bottom out, and things are slowly getting better.
Okay. And follow up to this was, is it true that the globe is experiencing natural cooling, or is the Earth still warming up?
No, there is no natural cooling evident in any of our climate records. So what we're seeing is really warming that is primarily a result of human activities.
Great, thanks.
Lucas, I'd like to just jump in here. Tony, there's a question I think is pretty important to you. Is your talk interpretable to mean that global warming is not necessarily occurring?
Is my talk interpretable?
Yes.
The question in my talk is global warming accelerating? So it's not whether or not global warming is happening, it's whether or not it's happening even faster than it has happened in the past.
Thank you.
So absolutely, the globe is warming. The only question is, has it started to warm even more rapidly in the last decade or so?
Great. I'm going to switch to Lori for a little bit now. So Lori, we got some questions from your presentation too. One of them was, why is the New Jersey coast one of the most rapidly warming ocean areas? You kind of discussed this a little bit during your presentation, I believe, but if you just want to elaborate.
I think, actually, I'm not sure if I have the data to answer that question.
Okay.
I might be able to help out there. So one of the things that has been shown by climate models for a while and is now starting to show up in the real world is that a circulation in the ocean called the Atlantic Meridional Overturning Circulation has been slowing down as a result of a changing climate. And that circulation at the surface of the ocean is what allows warmer waters to move up into higher latitudes, say the area between Canada and the British Isles and Scandinavia. If that circulation slows down, more of that heat can be retained in the area off the Northeast and Mid-Atlantic coasts. And there have been some studies showing that that's the reason for the warming.
Lori, we've had two requests for this. I don't know if you can answer this, but how do the multi-stressor events affect whales?
I don't think we don't have the data in our lab to answer that question, but whales are much more mobile than the organisms that we saw in this die-off, like fish and lobsters and crabs. So whales are more able to move away from unfavorable conditions than other organisms are. We also have no reason to believe that they would be more susceptible to low pH. That affects organisms that make their own shells and use calcium carbonate for their exoskeletons. So we don't really have the data to answer that question, but those are just some ideas.
Great, thank you. Next question I have is kind of for a general one for the whole panel. According to some recent reports, we've recently hit the 1.5 degrees Celsius target. What are the consequences of this?
Small question.
It's indicative of continued global warming. That 1.5, there's nothing magical about that. It was an aspirational goal, if you wish, to put it that way. One that personally, I think I saw it being exceeded pretty readily, and it's getting that way. But you know, any continued warming has consequences in a multitude of directions.
I think it's important to note that some of these lines in the sands that we draw don't necessarily represent tipping points to a catastrophe. They're just continuations along that spectrum. So going from 1.4 to 1.5 doesn't mean suddenly everything's bad. It means it's steadily worse, as it were.
A good way to think about the 1.5 degree limit is like the speed limit sign on a highway. We all know that the faster you drive, the more danger there is if something goes wrong. And if we wanted to reduce the danger as much as possible, we might set the speed limit at 10 miles an hour, but that's not practical. So the same way with climate change, the larger the change, the more risks there are, the more impacts there are going to be. That target was set, as Dave said, as something to aspire to. And it doesn't mean that if we suddenly go to 1.6, that there's going to be a bigger change than there was going from 1.4 to 1.5. The larger the change, the bigger the impacts.
All right, I have a few questions here. They're kind of related, which we'll see who wants to respond to these. They have to do with kind of like the impacts of the science. So first one was, how well do you think this science is being used for decision-making in New Jersey at state and county levels? And we also received one about what are the top 3 solution-focused things New Jersey residents should be petitioning for based on this data? And finally, is there any sign that New Jersey's progressive action is making any difference somehow? So based on all of your experiences, is there anything did you see the science being used in New Jersey, and do you see any positive impacts?
I am going to step in to say this is primarily a science report and document, so we're not going to necessarily be getting into policy discussions, especially if you're going to be asking our opinions on various policy interventions and the like. If you want to get our opinions, come find us separately. But Tony and Dave, if there's anything that you do want to comment on that you feel like you can in an official capacity.
Well, I think one thing that we can say is that the work that's been done on the science of climate change, both on a global scale and also here in New Jersey, is something that our elected leaders are aware of and, you know, presumably have taken into account in decisions that they've made.
All right, thank you.
Yeah.
Lori, we got a question about so we need for the bottom and top waters to mix for marine life to be healthy?
No, not necessarily. Every summer we see stratification. We see warm surface waters and cold bottom waters. I think last year it was just a more extreme event than we normally see. It was very strong stratification. It lasted much longer than we typically see. And I think there was some evidence that there were maybe lower winds during the summer than there usually are. So that just limited the mixing and just exacerbated the problem of the low DO that was just isolated in the bottom.
Great, thank you. Just looking here. James, I don't know if we can answer this, but for the deaths attributed to wildfire smoke, does this count smoke inhalation deaths? Do the immediate fire zones, do you know? I don't know if we have that information.
I don't know if we have that information directly. I imagine that it would be recorded as such and like, you know, you take someone to the hospital or something, that it would be recorded as such. But in terms of like the statistics stuff that I pulled, those are aggregate data. I'm not 100% certain how that's broken down.
We've gotten some questions regarding greenhouse gas emission trends in New Jersey. And specifically, I know our presentations, they focus mostly on global greenhouse gas emissions. If you can just talk a little bit about why those are being, the greenhouse gas emission data you are using and why New Jersey's, is or isn't important in that analysis.
Yeah, so keep in mind, New Jersey's a part of a larger whole. And if you're interested in New Jersey and greenhouse gas emissions, the state DEP does have its own greenhouse gas inventory that I encourage you to look at. It breaks it out by sector. It's a pretty nice report that they produce. But we focus on the global climate trends because even though we can affect that a little bit, we're still a little state of New Jersey, and our local emissions are not what cause our climate effects. Global scale emissions are what cause our larger climate change and changes in climate patterns that affect us here in New Jersey. So that's why we focus on those larger global effects rather than looking at New Jersey emissions. Now, don't get me wrong, changes in New Jersey emissions are important because we are collectively as a world trying to reduce emissions and those ramifications are global. But in terms of like the fraction of New Jersey emissions that cause specifically New Jersey climate change is very, very small.
Now, one thing I like to say is that a molecule of carbon dioxide has the same effect on our climate here, whether it's emitted in New Jersey or New Zealand, because greenhouse gases are well mixed in the atmosphere. And so we can't, it's not like other forms of pollution where the effects are primarily local, the effects are global.
I just want to make a note. So I have seen some questions regarding the impacts of different types of climate change on different sectors specifically, such as health as well as flora and fauna. These are probably not really relevant to our audience here today, but I would recommend to please follow up with us via email. And we can try and get answers to some of those questions by reaching out to some of our other colleagues here at Rutgers. I have a question here about, does positive feedback from ice melting and increased evaporation contribute to accelerated global warming?
Oh, absolutely. Something I've been studying for years with snow cover is an albedo effect, the reflectivity effect. That's just one way of looking at it. If you get rid of the highly reflective snow and ice covering portions of the polar regions that sneaks down into the middle latitudes during particularly northern hemisphere winter, you reduce that. The ground is and the oceans have a lower reflectivity, meaning they absorb more solar radiation. And that in turn will warm the atmosphere as well as the land and oceans themselves. So there's a huge relationship between the two. In fact, I've worked with some Canadian scientists with the wildfires last year. There was a high pressure system that helped to melt the snow off earlier in Canada. Once that snow was gone, it helped to warm and dry those areas quickly, and it helped to promote more of the forest fires. I'm not saying the melt of snow directly caused it, but it was a contributing factor once the atmosphere helped to get rid of that snow. So big impacts. And again, as Tony was saying, it doesn't have to happen locally. It could happen in New Zealand. It could happen in northern Canada, and we will feel the effects. I think the smoke from last year was a really good sign of that there are no borders when it comes to our atmosphere or our oceans for that matter.
We had general questions about our New Jersey greenhouse gas emissions climbing. I don't know if anyone here can respond to that directly, or if that's something that's directly to the DEP with their greenhouse gas emissions inventory.
I forget the number off the top of my head. I have looked at it recently, but I would direct you to take a look at their greenhouse gas inventory.
Okay. Let's see what else we have here. One question we've got is, they understand that the more vegetation, forest, et cetera, the more rain, it generates the small rain cycle. Doesn't that correlate with the fact that there's more rain over the northwest forests of the state? And that for areas that aren't covered with vegetation, it's drier, which can lead to desertification. Sorry, complicated word for me. And is this very dangerous to the future of agriculture in New Jersey?
So the northwestern parts of New Jersey get more rain for a variety of reasons. And I think if you go to Dave's state climatologist webpage, he talks a little bit about the reasons why we have the precipitation patterns we do. We have higher elevations there. That part of the state is further north, and closer to the storm tracks that bring precipitation to New Jersey. So it's not just about vegetation. Vegetation may contribute to some degree, but you know, the pine barrens are pretty well vegetated too, yet it's drier down there because of these other mechanisms involving elevation and latitude.
We had a few questions that we received actually via email that I want to just bring up. So James, so in your presentation, there was no mention of DEP monitoring network and of that data, but you talked about it being from EPA now. Can you just speak briefly about why that data was used?
Yeah, so for the wildfire and like the smoke and air quality data, we pulled that data from the airnow.gov website, which incorporates EPA as well as DEP sources for New Jersey at least. So those data are represented, just not explicitly in that, mainly because to actually pull the information, we went through EPA. They're the ones serving up the data for us on that end.
Luke, I think we have time for one more question.
All right, we have one from the chat here. In light of the expectation that the ocean water temperature is getting warmer, can we explain why the water temperatures have been so cold to this point?
Yeah, that's Laura, you want to handle that?
So off the coast of New Jersey, the bottom waters is there's a cold pool with a perpetually cold pool of water. And in New Jersey, we have upwelling. So that cold water, when conditions are right, the water upwells to the surface. So along the coast will be very cold water sometimes in the middle of summer. So there's a lot of things that play with sea surface temperatures, and sometimes we get cold water that upwells along the coast.
Well, and one of the ironies that it's often when we're having the hottest weather that we get that upwelling, because the winds from the south and southwest, through the complicated physics of the way the air interacts with the ocean and friction and the Coriolis effect, when we get those winds from the south and southwest, it pushes water at the surface away from the coast. And as Lori said, then you get the upwelling of this cold pool of water that lies further below.
Thanks, folks. I'd just like to say that I have put in the chat on behalf of James Shope, our co-organizer and lead author of the report. If folks can please take a minute at the conclusion of today's webinar to complete a short survey about today's presentation. It's in the chat. I put in Dave's website. Again, you can find this report on the New Jersey Climate Change Resource Center website, and I put the links in there, as well as we hope we'll have a recording of today's webinar available hopefully before the end of the week. So on behalf of all of us here at the New Jersey Climate Change Resource Center, we'd like to once again thank our distinguished panelists, James Shope, Dave Robinson, Anthony Broccoli, and Lori Garzio. And this concludes today's event. Thank you. And again, if you have questions, email us. We couldn't get to everyone, but I think we got to most of the scientific questions, and we'll be happy to see where we can follow up with you. Thank you.